equals 0. And I want us to solve for x. So the first place my brain is going to is, all right, this could potentially be factorable, right? How do I know that this could potentially, that factoring is on the table? How do I know, Charlie?
Because has a fourth, like it's like double the next ones.
Yep. So we have the same base of x and one exponent is double the others. So that tells me factoring is on the table. So we would try to factor this. I will tell you, we are not able to factor this. It will not work out. So now I have to think of another way to solve. Why am I not able to use the quadratic as it is? The quadratic formula. Excellent. So the quadratic formula only works on quadratic equations. And how do we identify in a quadratic equation? The highest exponent has to be 2. So this is not a quadratic equation. But what I'm going to do is I'm going to manipulate things so I can use the quadratic equation. So what I'm going to do is I'm going to say let m equal x squared. So if m equals x squared, m squared will be x to the 4th. So now this is going to be 4m squared minus 16m plus 13 equals 0. Now that I've used substitution, can I use the quadratic formula of 4m squared minus 16m plus 13? Absolutely. So we have m is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And just to identify, our a is 4, our b is negative 16, and our c is a positive 13. And now all we're going to do is plug right in. So m will equal, the opposite of negative 16 is a positive 16, plus or minus the square root of negative 16 squared minus 4 times 13 all over 2 times 4. And now we start simplifying. So we have m is equal to 16 plus or minus the square root. 16 squared is 256. And then we're going to have a negative 4 times 4 is negative 16. Negative 16 times 13 is a negative 208 all over 8. Keep simplifying. So now we have m is equal to 16 plus or minus the square root of 48 all over 8. We can absolutely simplify the square root of 48. I could split that into 16 and 3. So this becomes 16 plus or minus 4 root 3 over 8. What will be our last step here? Well, the last step in this part of the process, Leo. Yep, pull out a GCF of 4 and simplify. So we're going to get 4 plus or minus the square root of 3 all over 2. Now be careful. We are not done. M is equal to 4 plus or minus the square root of 3 over 2. Was I solving for M? No, I used that to help me out so I can use the quadratic formula. I'm solving for x. So now I have to substitute back in. So we said m is the equivalent of what? M subbed in for x squared. So now this is going to be x squared is equal to 4 plus or minus the square root of 3 over 2. And now to solve for x, I have to undo a square. How do I undo a square? Take the square root. And now when I go to take the square root, because I'm solving and taking the square root, what do we have to account for? Plus minus, very good. So now we're going to have x is equal to plus or minus the square root of 4 plus or minus the square root of 3 all over the square root of 2. I am absolutely allowed to have a radical within a radical. Perfectly fine, not a problem. What is the problem here, though? Okay, square root of 2 in the denominator. So what must I do to fix this problem? Lily? You got it. We're going to rationalize. So we're going to multiply the top and bottom by the root of 2. Now be very careful here. When we multiply that numerator by the root of 2, because it's the same index, I can multiply their radicands. But isn't this radicand a binomial? This is a binomial. So when I multiply these, wouldn't I have to distribute in the 2? So be very careful there. We have to distribute in that 2. So when we distribute in that 2, we're going to get plus or minus the square root of 8 plus or minus 2 root 3 all over 2. How come it's not root 6? How come it's 2 root 3? Charlie?
Because like the root is already like it was already multiplied.
Yes. Good. Because the root, this root and this root are being multiplied. This is another root within. There's not another root within. So this 2 just distributes in, and it's the coefficient of that root 3. Okay, now, what was the degree of this polynomial? The original one that we had to solve for? It was a degree of 4, which means how many solutions should I have? 4. Do I have 4 solutions here? I do, because I have plus or minus on the outside of the radical, but don't I have another plus or minus inside that radical? So that's a total of 4 solutions. All right, let's try another one. So my initial instinct is I see x to the 8th and x to the 4th, same base, one exponent is double the other. So can we try factoring here? Yeah, my suggestion is if you can factor. Using the quadratic formula takes a really long time if it's not necessary. And this one's a pretty easy one to figure out. Can we factor this? Yeah, multiply to positive 16, add to negative 17. Absolutely. So we're going to have x to the 4th minus 16, and then x to the 4th minus 1. But now I'm looking at my 2 parentheses. Can I factor this further? Absolutely. I have 2 dots. So this becomes x squared minus 4, x squared plus 4, x squared minus 1, x squared plus 1. Am I done factoring? No, I have another dots. So now I have x plus 2, x minus 2, x squared plus 4, and then the dots here, x plus 1, x minus 1, and then x squared plus 1. Is there anything else I can factor? No. So now I'm going to set all of my factors equal to 0. So we have x plus 2 equals 0, so x will equal negative 2. That's one solution. X minus 2 equals 0, x will equal a positive 2. That's a second solution. X squared plus 4 equals 0. Subtract that 4 over. Square root both sides. X will equal plus or minus what? 2i. Very good. That's 2 more solutions. x plus 1 equals 0, x will equal negative 1. X minus 1 equals 0, x will equal a positive 1. And then lastly, x squared plus 1 equals 0, x squared equals a negative 1. Square root both sides, x will equal plus or minus I. How many solutions is this in total? 8. What was the degree of my polynomial? 8. So should I have had 8 solutions? Yes, and we have all 8 solutions. Okay. All right, you guys try this one. Let me see how you go about it. We'll go over it together. So just a reminder here, how many solutions should you have at the end of this? 6. If you end up with just 2 solutions, that's not right. You should have 6. Debarshi, there's no reason you should have your computer open. All the way, Debarshi. Close your computer all the way. Who wants more time? Okay. Okay, so I look at this, I see they have the same base of x. I see that one exponent is double the other, which tells me I could potentially do what? Factor. We can potentially factor. So I'm going to go ahead and I'm going to factor, and we're going to get x to the third minus 8, x to the third plus 1. Now, if you went straight to solving here, and you said x to the third equals 8 and x to the third equals -1, and then you cube root both sides, you would have gotten x is equal to 2 and x is equal to -1. How many solutions is that? Only 2. What does that tell you? We did something wrong here. This is not how I should have done it. So then we erase and we go back. We say, okay, well, maybe I shouldn't have solved. Let's look at these parentheses again. X cubed minus 8. It's not a dot, but what is it? A difference of cubes. And x cubed plus 1 is not a dot, but isn't that a sum of cubes? So that's what we have to do. So this becomes x to the first raised to the third minus 2 raised to the third. And this becomes x to the first raised to the third plus 1 raised to the third. So when we factor further, this difference of cubes, we're going to have an a minus b, so x minus 2 times a squared x squared plus ab, 2x plus b squared is 4. And then for the sum of cubes, we're going to have an a plus b, so an x plus 1, times an a squared x squared minus ab, so minus x plus b squared, which is 1. Now remember, I've always told you, once you factor the sum of cubes or difference of cubes, can that trinomial be factored more? No. So now we come to solve. So we said each factor equal to 0. And here I will get x equals positive 2, which is one solution. And now I have x squared plus 2x plus 4 equals 0. I know I can't factor this. So in order to solve this, what should I use? Quadratic formula. Good. So we're going to get x is equal to negative b, so negative 2 plus or minus the square root of b squared, which is 4, minus 4 times 1 times 4 all over 2. So we're going to get x is equal to negative 2 plus or minus the square root of 4 minus 16 all over 2. Now we're going to get x is equal to negative 2 plus or minus 2i, because it's going to be a negative 12. So 2i root 3 all over 2. So x is equal, if we pull out a GCF of 2, negative 1 plus or minus I root 3. That's 2 solutions right there. So those are the first 3 solutions. Yes. Yeah, if you wanted to, you could use complete the square. All right, next one, we're going to have x plus 1 equals 0, so x equals negative 1. That's your 4th solution, so we need 2 more solutions. So here we have x squared minus x plus 1 equals 0. And I'm going to use quadratic again. X equals negative b, so that's a positive 1, plus or minus the square root of b squared, which is 1, minus 4 times a times c, which is just a 4, all over 2a. So x will equal 1 plus or minus the square root of negative 3 over 2. So x is equal to 1 plus or minus I root 3 over 2. And those are your last 2 solutions. So we have 6 solutions in total. The degree of the polynomial was 6, so we're good. What number was this? 2? 3? Okay, back to number 4. What do I hope you realize here?
You just kind of replace the x squared minus 3 with the variable. It's like
Yeah, that we have some quantity to the fourth power, and then we have the same quantity to the second power, which means we could potentially do what? Factor. So what I'm going to do is I'm going to use substitution. I'm going to let m equal x squared minus 3x. Are we okay with the fourth and the second power? I think we're okay with that, right? Factoring with that. So this just becomes m to the fourth power plus 5m to the second power plus 6 equals 0. And now we could absolutely factor. We're going to get m squared plus 3 and then an m squared plus 2 equals 0. Can I factor any further? No, this is definitely not a dot. It's not a cubes because there's nothing raised to the third power. And there's plus signs here. So like I said, we keep going. We go to solve now. So when we go to solve, I'm going to have m squared plus 3 equals 0 and m squared plus 2 equals 0. So now we get m squared equals negative 3. To undo a square, what must we do? Take the square root. So now I'm going to have m is equal to plus or minus I root 3. On the other side, we're going to have m squared equals negative 2. Once again, to undo a square, we're going to take the square root. So m will equal plus or minus I root 2. Can I stop here? No, I wasn't solving for m. What was I solving for? X, so I have to substitute back in. So x is equal to, m is equal to x squared minus 3x. All right, bear with me. I'll let you all catch up now because this is going to be a little bit different. We have an x squared, we have an x, which tells me when I solve this, I should get another 2 solutions from this. Do we agree? From what we have. Okay, I obviously can't factor because of that plus minus I root 3. I'm going to go with the quadratic equation and I'm going to show you what we're going to do. So we're going to have x squared minus 3x. I'm going to bring that plus minus I root 3 over. So it's plus minus I root 3, meaning if it was a plus I root 3, I'd subtract it. If it was a minus I root 3, I'd add it. And we're actually allowed, instead of doing the quadratic twice, which would be a pain, we're just going to do the quadratic using plus or minus. And I'll show you what I mean. We're going to have a is equal to 1, b is negative 3, and c is plus minus I root 3. So instead of doing c a positive I root 3 and then c a negative I root 3, we're allowed to just use it as 1. So now x will equal negative b, so that's a positive 3, plus or minus the square root of b squared, which is 9, minus 4 times a, which is 1, times c, which is plus or minus I root 3, all over 2a, so that's all over 2. Everybody okay with how I've plugged in so far? Any questions on anything I've done? Okay, let's keep going. So now we're going to have x is equal to 3 plus or minus the square root of 9. And now I have negative 4 times plus or minus I root 3, which gives us a plus or minus 4I root 3. Do we agree there? Yes. Exactly. Yep. All over 2. Can I split up this radical now and say, oh, square root of minus 3, square root of 4 is 2, and just get rid of this radical? Can I do that? No, because this is a binomial underneath of this. So this is all in together. Unless there was a perfect squared GCF that I could pull out of it, nothing's coming out of this. And we can't split a radical through a plus or minus sign. So here is a solution. Technically, how many solutions is this? This is 4 solutions. Now let's go to the other part of this. And I'm going to do the same thing. M is equal to x squared minus 3x, which equals plus or minus I root 2. I'm going to do the same exact thing I just did. I'm going to move this I root 2 over. And then I'm going to use the quadratic formula. I want you guys to try this now on by yourselves. Use the quadratic formula, and let me know what you get. Who has an answer here? Charlie?
3 plus or minus square root of 9 plus or minus 4 I root 2 over 2.
That's what I got. Does anybody want to see me do this? Right. Isn't this another 4 solutions? Now, somebody might say, well, that's a total of 8 solutions. I thought we were only supposed to have 4 solutions because the exponent was 4. But was it really 4? No, because this is saying x squared minus 3x multiplied by itself 4 times. If you take x squared minus 3x and multiply it by itself 4 times, what will be the highest exponent? X to the 8. And there's our 8 solutions. All right, let's do another one. Okay, so what I see, what catches my eye right away is that these two have the same radicand. Do you guys notice that? So I'm going to say, let's change this to exponential. I have x minus 2 raised to the half power. And then I have an x minus 2 raised to the half, but then raised to what? Another half. You got it. And a power to a power, what do we do? Multiply. So this is going to be x minus 2 raised to the half power plus x minus 2 raised to the 1/4 power equals 2. What is it that I hope you realize right now, Ariana? Good. A half is double 1/4. And don't they have the same base? So what can I do? Factor. So I'm going to use substitution. I'm going to let m equal x minus 2. So I have m to the half plus m to the 1/4. I'm going to bring that 2 over. Minus 2 equals 0. Are you guys okay if I leave the half and the fourth? Working with that while we're factoring? So we always go to the smaller one. So this is going to split into m to the 1/4, m to the 1/4. And then we need factors of -2 that add to a +1. So that's a +2 and a -1. All right, I'm going to sub back in right now. So for this, we wouldn't really know because of the 1/2, the 1/4. It's not like one of those things where it's like x to the 8th, x to the 4th. We know we need 8 solutions or we know we need 4 solutions. Now we're just trying to solve. So here I'm going to say m to the 1/4 equals -2 and m to the 1/4 equals +1. And now I'm going to sub back in. What does m represent? Good, x minus 2. So I'm going to have an x minus 2 raised to the 1/4 power equals -2. Now I want to get rid of that 1/4. What would I raise that 1/4 power to get it to be 1? 4. So I raise to the 4th power on the left. I raise to the 4th power on the right. So here we're going to get x minus 2 is equal to -2 to the 4th power, which is 16. So x will equal 18. Because this was a radical equation, what do I mean when I say a radical equation? The original problem was a radical equation. What do I mean when I say a radical equation? There's radicals. All I heard was there's something radicals. Good. There's radicals in this equation. And because there's radicals in the equation, remember, we can get extraneous solutions. So now we need to check for extraneous solutions. So we're going to take that 18 and we're going to check it. When we check 18, 18 minus 2 is 16. Square root of 16 is 4. All right. 18 minus 2 is 16. Square root of 16 is 4, but then the square root of 4 is 2. Is 4 plus 2 2? No. So what do we have to do with that 16? I mean, that 18. Reject it. We're rejecting it. That's an extraneous solution. It doesn't work. So now we have to go to the next solution we have, and we're going to have x minus 2 equals 1. Add that 2 over, we're going to get x equals 3. Do we still have to check the 3? Yeah, just because one is an extraneous solution doesn't mean the other one automatically works. They could both not work. So let's plug in that 3. 3 minus 2 is 1. Square root of 1 is 1. 3 minus 2 is 1. Square root of 1 is 1. Square root of that 1 is still 1. 1 plus 1 is 2. Does that answer work? Yes. So we have one solution here, x equals 3. All right, I have 2 more problems I want to show you. So I think a lot of people might look at this and be like, let's rationalize and eliminate. Let's rationalize or eliminate the denominator, rationalize, then eliminate whatever it is you might be thinking of. I'm looking at it a little bit differently just for quicker purposes. I see an x to the first, and what is this? X to the half. What does that mean? This exponent is double this exponent, and they have the same base, which tells me we could potentially do what? Factor. Had those variables been where? In the Numerator. Can I make them in the numerator? Yeah, I could have 2x to the negative first power. Isn't that bringing that up? Plus x to the negative half power. Isn't that bringing that one up? And then I'm going to subtract that 1 equals 0. Can we factor this? Absolutely. So we're going to have 2x to the negative half power minus 1, and then x to the negative half power plus 1. You could check that middle term by multiplying the outers and the inners. 2 times 1 is 2. Negative 1 times a positive 1 is a negative 1. 2 plus a negative 1 is a positive 1. And now we solve. So we have 2x to the negative half power equals positive 1. I just moved that 1 over. Divide by 2. So now we have x to the negative a half power equals 1 over 2. Are we good so far? So do you guys want to now solve this leaving it an exponential, or would you have changed this to a radical? What would you do? Either way, it works. Exponential, sure. Let's go through this exponential. I probably would have done that also. So we're going to raise this to what? To get it to have an exponent of 1. Negative 2. We raise it to a negative 2 second power. Raise this to the negative second power. Everybody okay with what I'm doing so far? Yeah? Okay. So now this cancels, and I'm going to get x is equal to, now how do I make that negative exponent positive? Flip it, right? So this becomes 2 over 1 raised to the second. And what's 2 to the second power? 4. Do I have to check this? Yeah, but this time I only have to check what? The denominators, right? So if I have 4 in the denominator, am I okay? Yeah, I just can't have 0 in the denominator. So we're good there. Now we're going to do the other side. We're going to get x to the negative half power equals negative 1. What am I raising this one to? Negative second again. So now we're going to have x is equal to negative 1 flipped is still negative 1. And then negative 1 to the second power is positive 1. That also works. Oh, wait, does positive 1 work? Oh, this doesn't make sense, guys. The 4 works. Positive 1 doesn't. So we actually needed to go through, didn't we? All right, sorry guys. So it's not just about checking the denominator. We actually need to go through. So when we check the positive 1, you're going to have 2 over 1 plus 1 over 1, right? Does that equal 1? Does 2 plus 1 equal 1? No. So sorry, we did have to check more than just the denominator. So the positive 1 does not work. All right, last problem. I want you guys to try this one on your own. What do you think I'm going to recommend you do? Starting point. Ariana? Switch to exponential. My advice to you is switch to exponential. That's your starting point. Are we ready? Anybody want more time? Ready? Okay. So let's just see. Let's get answers first. Does anybody have answers? Ariana? Those are correct. How many people got that? Good job. All right, let's go through it for the people that didn't get it. So my advice to you was change to exponential. And why was I changing to exponential? Because I realized they had the same base of x. So I'm like, oh, let me see if one exponent's double the other, and then we could potentially factor. So that's where my head was at. And is 2/3 double 1/3? Yes, so we can factor. Easy factoring, so x to the 1/3 minus 4, and then x to the 1/3 plus 2. And then we go and solve, and we're going to get x to the 1/3 equals 4, and x to the 1/3 equals -2. We're going to cube both sides. So we're going to get x is equal to 64, cube both sides here. X will equal -8. Would you have to check? Yes. Do they both work out? Yes. So we are done.